welcome to SB Union High School and Junior College. Today we are going to discuss about the scheduling. What is a process scheduler? We have seen in previous topic what is a process, but how these processes are scheduled, that is how these processes are executed, that we are going to learn in this topic in detail. Now, first we'll see what is a scheduling. As the name shows, scheduling means to make the timetable of that processes, how those processes are going to schedule. Scheduling is a process which allows one person to use the CPU while the execution of another process is on hold due to unavailability of any resources. Its aim is to make system efficient, fast and fair. That, as we know, we create the processes. For one or each and every program, the number of the processes are created. But to execute that particular program or the application, it will execute the number of the processes. Then we have to decide which process is going to schedule or execute on what particular time. To schedule all these processes come under the topic of the scheduling. We require the scheduling, and when the process are scheduled, then that system will work in very efficient and fast manner. Now we'll see when to schedule a process. When a new process is created, a decision needs to be made whether to run the parent process or child process. Okay, we know that. As we have seen, Word application is created. For example, MS Word example. We create or we open that MS Word application program, then one process is created. We are going some application, another, that is the MS Excel, then one more process is created. Again we come to the MS Word, then again that process is created. We know that there are the types of the process. One concept is a parent process and a child process. So in this case, what happens is we cannot recognize, we means the system cannot recognize that which process has to execute, either parent process or the child process. Then we require the schedule that particular process. A scheduling decision must be made when a process exists. Now, if that processes exist, then we have to do the scheduling. When input-output interrupt occurs, a scheduling decision may be made. Sometimes what happens is, in execution of the process, that particular input or output resources are not available. That time what to do? The process interrupts. Okay, then again when to process that execute, from which timing or from what that stops to execute again, that we have to decide. So all these concepts comes under the scheduling. So as the name suggests, scheduling. So what do we know from the scheduling, or what we can understood from the scheduling? As the program or application opens, the process are created. Again the sub processor or the parent child processes. So there is number of the processes for one application program, and those are in queue. Some processes within a ready state, some in a waiting state. There are the different states are there for the state in a process life cycle. So depending on that, some are waiting for the input output resources, means if that particular input and the output is available, then that particular waiting process take and it will go into the execution. Some are waiting with the ready with all the resources, but previous process finishes, then it is going to execute. So these are the different states are there, and we do this by the scheduling. So there are the some objectives of the scheduling. First, fairness, some good throughput, then third, good CPU utilization, fourth, low turnaround time, fifth, low waiting time, and sixth, good response time. So these are the number of objectives of the scheduling. So we'll see one by one in detail. Now we see the first, that is the fairness. So as the name suggests, it refers to being fair to every user in terms of CPU time it gets. All jobs should get fair chance to get the use of CPU. Means what? Whatever the processes are there in a queue, everyone can get the timing of the CPU to execute. So there should be the fairness. Second, throughput. It refers to the total productive work done by the users put together. It is the total number of process completed per unit time. As we know, for each and every application, the number of the processes are created. And when those processes are executed, then it will turn that application done. So all these works in productive works in put together, it is called as a throughput, and it is a total number of processes completed per unit time. So this is about the throughput, means whatever the work done by that processes. Next one is the CPU utilization. As we know, why the scheduler required to take the utilization of the CPU. So it is the fraction of time the CPU is busy on an average with the user, processes or the operating system. Okay, means every time the CPU is doing some work. Doing some work means what? That processes are undergoing in process, means it taking the time of the CPU. Means it is in a use of processes or the operating system. Computer uses of memory and processing resources or amount of work handled by the CPU. Therefore, throughput will be low, but CPU utilization will be very high. As we have seen that processes can take the CPU when it's undergone the execution. So what happens is whatever the total work done by that processes will be low, but how that use of the CPU is takes place by the particular process, that will be high. So there will be variation. So it is called as a CPU utilization. Some process can take the more utilization of the process, that is the CPU, and some process can take the some little utilization of the CPU. So it is throughput will be low, but utilization of the CPU will be high. Then next, low turnaround time. It is the elapsed time between the time a program or a job is submitted and the time when it is completed. Means when that program is going under the execution, that is the starting timing, submission, and when that particular process completes or the program completes. So what is the time in between? That is the submission to the completion. It is called as a low turnaround time. Next, low waiting time. It is the amount of time a process waits to load itself on the CPU. Means to load the process, means gauge the attention of the CPU, means it is loading on the CPU. So what that particular time is required to load the process on CPU, it is called as a low waiting time. Waiting time means what? When the previous process stops the execution, then next process comes and execute. Then next one is the response time. Amount time it taken from when a request was submitted until first response is produced is called as a response time. Okay, so whatever the amount it required when the request is submitted for the response, it is called as a response time. So these are the some objectives of the scheduling. So we have seen scheduling, when the scheduling is required, and what are the different objective of the scheduling. So this is about the scheduling. Thank you.